And now we're going to talk about literal expressions. So when we are saying a literal expression, what we mean is an expression that uses words to give a literal meaning to a relationship between variables. And it's very important to be able to take a literal expression, like here, the sum of x and y, and be able to translate it into the equivalent algebraic expression or equation, because that's really the skill that we use to take a word problem and solve it with algebra. In this section, we're going to talk about just the very basic expressions, and we'll kind of build on our vocabulary as we go through studying algebra. The first expression features the keyword sum. And when we say that we're concerned with a sum is a result of an addition problem. So the sum of x and y is really the same thing as saying the result of adding x and y. Difference. Now, when we use the word difference, difference is a result of subtraction. And the order matters, of course, in subtraction. So when we say the difference of a and b, the correct way to write that is a minus b, because a comes first, and so it should come first in our subtraction problem. In the next phrase, the key word is product. The product is a result of multiplication. And so when we say the product of m and n, we are saying the result of multiplying m by n. So we would write that as mn. Remember, since we're not writing a sign between m and n, we mean multiplication. Finally, the quotient of u and v. Quotient is a result of division. And just like in all the previous cases, the order matters. So what we want to say is u divided by v, or if we use algebra notation, we would write it as a fraction u over v. Remember, u came first, so u goes on top. So those are four key important words: sum, difference, product, and quotient, results of adding, subtracting, multiplying, and dividing. Now let's take a look at a few more examples. So this one is slightly more complicated. We have more things going on. So we're talking about the sum of 12 and the product of x and 16. Obviously, sum and product are very important keywords. How do they play into it? Well, let's read the sentence. So it says the sum of. When we say the sum of, we mean we are going to add two things. Sum is the result of adding two things. Now, what are those two things? The first thing is 12, right? The sum of 12 and the product of x and 16. This whole thing, the product of x and 16, is the second number. So I'm going to try to write this out in as much detail as possible. What we are saying is it's the sum of 12 and the product of x and 16. Now, of course, we didn't finish translating because we have to figure out what the product of x and 16 means. And remember, the product means multiplication. So we have product of x and 16. What are we multiplying? X and 16. So 16x, 16 times x. The reason why I wrote 16 first is because in multiplication, the order doesn't matter, and usually we write the number first and the variable second. And so there we have the sum of 12 and the product of x and 16. This is our final answer. This is the expression that corresponds to that phrase. The next example that I wanted to go over is, it's not terribly complicated, but it gets a little bit confusing. So 17 less than x. Of course, the word less implies that you're going to subtract at some point. It's just a question of what from what. And it's a little bit of a confusing phrase because here 17 comes first, x comes second, but in reality, the way that you should write this if you're going to do it correctly is x minus 17, not 17 minus x. The second number comes first, the first number comes second. And the reason is just the way that the grammar works. For example, if we did plug in a number into x, let's say 17 less than, for example, 20, how would we interpret that? Well, we would interpret is we started with the number 20, and we want to be 17 less than that, right? We would go all the way down to 3. We're 17 less than 20. It's 20 minus 17. It's a little bit of an awkward phrasing because when this is the correct way to write it in English, but when we translate it to math, you have to reshuffle the x and the 17. So I wanted you to be comfortable with this example. That's why I'm explicitly talking about it. When you see less, it is subtraction, but you have to switch the two numbers. Okay, so we talked about literal expressions, and we are now ready to start talking about techniques for simplifying variable expressions, taking a variable expression and writing it in simpler terms. And the technique that we will discuss in the next video is called the distributive property.